Hello everyone. This video is a technical demonstration of the project done by Shruti, Vaijayanti, Vaidishwari and Harini under the guidance of Mr. Muthu, Assistant Professor in the Department of Biomedical Engineering, SRM University. The title of our project is Fabrication and Finite Element Analysis of 3D Scaffold-based Femur Bone Repairing. The aim of our project is to fabricate a 3D scaffold for bone tissue regeneration and perform FEA analysis for the same. The objective of the project is to improve the mechanical strength of the scaffold by using the new combination of sodium alginate, chitosan and polycaprolactone. The potential of PCl, chitosan and sodium alginate as an effective material for bone tissue regeneration will be evaluated. The general methodology of our project is to fabricate two scaffolds and compare the mechanical strength of both the scaffolds. The first scaffold is made by using sodium alginate and chitosan using a freeze-drying technique. The second scaffold is made as a continuation of the first scaffold by impregnating PCl into the first scaffold. Both the scaffolds are given for SEM analysis, and using the results obtained from the SEM analysis, models of both the scaffolds are made and their mechanical strength is tested. Now let's go on to the experimental part.
Is dissolved in 30 ml of distilled water, and this is our distilled water, and this is the glass measuring jar usually used to measure the solvents. And now we are measuring 30 ml of water, and this is the 10 ml measuring jar. Of distilled water is measured, and in that the 0.25 grams of sodium alginate that we measured is put into the distilled water carefully. Now this is our magnetic stirrer. We are putting the beaker into the magnetic stirrer, and this is the pellet. We are putting the pellet into the beaker, and then we have to switch on the machine and adjust our RPM. This is how the solution is formed using the magnetic stirrer.
Chitosan solution is formed by dissolving 0.15 grams of chitosan in 0.5% of acetic acid. It is magnetically stirred to obtain a homogeneous mixture.
Alginate and chitosan in the ratio 60:40, making up a 30 ml solution, and now we are stirring it by placing it in a sonicator. We are switching on. And the machine sonicator is now set to 180 seconds, that is 3 minutes. We are placing the solution in the center of the sonicator and we are pressing on. Now we are taking out the solution. We can only see slight changes here. And this process is repeated for every 30 seconds. Now again we are keeping and switching on the apparatus until we get a fibrous solution.
The homogeneous solution of sodium alginate and chitosan is now kept in a freezer at -20 degrees Celsius for 24 hours. The freezed mixture is now kept in a lyophilizer to remove the moisture from it. It is kept in the lyophilizer for 48 hours. The resulting scaffold will be spongy and porous in nature. The SEM image of this scaffold is shown here. It clearly shows the porous nature of the scaffold. Now this scaffold is our first scaffold. Now the second scaffold is formed by dipping the first scaffold into the PCl solution. The PCl solution is formed by dissolving PCl pellets into dichloromethane solution. The scaffold is dissolved in the PCl solution for half an hour, and then it is exposed to normal environment condition where the dichloromethane evaporates and the PCl will be impregnated into the scaffold. This technique is called solvent evaporation. By using this technique, our second scaffold is formed. Our second scaffold now contains sodium alginate, chitosan and polycaprolactone. This scaffold is also given for SEM analysis. The SEM image of this scaffold also shows it contains many pores. The FTIR analysis is also done for both the scaffolds. The FTIR analysis of both the scaffolds shows that all the polymers are combined within the scaffold. We have to check whether the mechanical strength of the scaffold is improved or not. This is done by performing the FEA analysis. Here we use three softwares, namely SolidWorks, HyperMesh and ANSYS. SolidWorks is used to model the scaffold, and meshing is done to convert the infinite elements present in the model to finite number of elements, and finally the analysis is done using the ANSYS software. Modeling. A unit cell of the scaffold is modeled by using the pore size obtained from the SEM image. Front plane is taken as the reference plane. This square box represents the base of the scaffold. The pore diameter obtained from the SEM image is used as a reference, and central circular part of the base is removed. This process is repeated in all the planes. As a result, a porous unit cell model is obtained as shown here. Meshing. 2D and 3D meshing are done on the unit cell in order to convert the infinite number of elements into finite number of elements to perform the analysis on the model. The elements of our interest are now assigned on the unit cell model. This figure shows the scaffold 1 consisting of sodium alginate and chitosan. The red portion represents the sodium alginate and the blue portion represents the chitosan. This image shows the scaffold 2 containing sodium alginate, chitosan and PCl. Here again, red portion represents sodium alginate, blue represents chitosan and the pink portions represents the PCl. The elements are assigned on the model based on the ratios used for fabricating the scaffolds. That is, 60% of the elements consist of sodium alginate, 40% of the elements consist of the chitosan, and the remaining represents the PCl. Analysis using ANSYS. Now the mechanical strength is tested in the ANSYS software. Von Mises stress is applied on the scaffold. Von Mises stress represents the application of stress on the scaffold from 6 directions. This figure represents the analysis of the scaffold 1, and this shows the analysis on the scaffold 2. The red region on the bar represents the maximum stress that is produced on the scaffold on the application of forces. This figure represents the comparison of the mechanical strength between the two scaffolds. Blue bar represents the scaffold 1 consisting of the sodium alginate and chitosan, and the red bar represents the scaffold 2 consisting of sodium alginate, chitosan and PCl. Here we can see that the stress value of the scaffold 2 is less than the scaffold 1, showing that it is mechanically stable than the previous scaffold. The addition of the PCl has made it more mechanically stronger than the first scaffold. The strength of the scaffold is now tested by fitting it into a damaged bone. A femur bone is modeled using SolidWorks. The damaged portion of the bone is removed. The scaffold is now modeled and is fitted into the damaged portion of the femur bone. The red portion signifies the scaffold fitted into the femur bone. Meshing. 2D and 3D meshing is done on the femur bone fitted with the scaffold. This represents the scaffold 1 fitted into the femur bone. Here also the red portion signifies sodium alginate, blue signifies chitosan, and the green portion signifies the bone. This shows the scaffold 2 fitted into the femur bone. Here the addition of the pink portion represents the PCl. Now the analysis is done using the ANSYS software. Von Mises stress is applied on the bone. This stress is applied from all the 6 directions on the bone. This shows the analysis of the scaffold 1 fitted into the bone. This represents the analysis of the scaffold 2 fitted into the femur bone. Here also, the red portion in the bar represents the maximum stress produced on the application of the force on the bone. The figure represents the comparison of the mechanical strength between the scaffold 1 and the scaffold 2. Here, the blue bar represents the scaffold 1 consisting of sodium alginate and chitosan, and the red bar represents the scaffold 2 consisting of sodium alginate, chitosan and PCl. Here also we can see that the stress value of the scaffold 2 is less, indicating that it is mechanically stable than the scaffold 1. Thus here we have proved that addition of PCl has improved the mechanical strength of the scaffold. Of our project is the addition of the new polymer polycaprolactone into the already existing sodium alginate and chitosan scaffold. Here we have proved that the addition of the PCl has improved the mechanical strength of the previous scaffold.